Let's see the next question in this exercise, question 817. In triangle ABC, right angled at B, the value of tan A, the ratio tangent A has been given as 1 over root 3. Find the value of sine A cosine C, cos A sine C. Now, if tan A is 1 over root 3, then angle A must be 30 degrees. And we can always solve by calculating sine of 30, cosine of 30. In fact, that's the simplest method. But what will happen if the numbers are kind of different and the value of that angle cannot be found out? So I'm going to go by a generic way. What I'm going to do is draw a right angle triangle, ABC, right angled at B. And let's say that tan ratio, which is opposite or adjacent. So for angle A, opposite is 1 and adjacent is root 3. Why am I marking this as 1? Because the numerator in case of tan is opposite and denominator is actually adjacent. So opposite, I'm going to mark it as 1, adjacent, I'm going to mark it 3. Since this is right angle triangle, I can use Pythagoras theorem and I can find out the hypotenuse as 1 square plus square root of 3 square. After addition, everything will be under square root. So that will come out to be 2 centimeter. So hypotenuse is the longest side irrespective of any angle what you are considering. So for A, this is hypotenuse. Even for C, this is also hypotenuse. Now, as far as A is considered, this BC is opposite. And AB is actually adjacent. But as far as C angle is concerned, this one is adjacent for C and this one is opposite for C. So the definition of hypotenuse remains fixed, constant, it doesn't change, but opposite and adjacent actually depend upon which angle you are considering. What is opposite for one angle can be adjacent for another angle or vice versa. So once this opposite and adjacent are well defined and also hypotenuse is now calculated, now we know all three sides of that right angle triangle. That will enable us to calculate sine, cosine and tangent ratio of any angle whatsoever within that triangle. So I need sine and cosine of angle A. I need sine and cosine of angle C. So let's keep them ready so that we will be able to substitute them in the given expression. So sine A is always opposite over hypotenuse. For A, opposite is 1, hypotenuse is always 2. So sine A is 1 over 2. Cosine is adjacent over hypotenuse. So that would be root 3 divided by 2. We can use the similar approach for angle C. Now for sine C, which is this angle, opposite will be directly facing in front of it. So that would be AB. So it will be root 3 divided by hypotenuse, which is 2. Similarly, cosine C is adjacent over hypotenuse. Adjacent is for C, this is adjacent, which is 1. And hypotenuse for everybody is just 2. So once we have these 4 trigonometric ratio ready, now I'm able to substitute them. It's just a matter of plugging in the values. So let's start with the first one, sine A cosine C plus cosine A sine C. Let's take this value from this area. 1 over 2 plus 1 over 2 times 1 over 2, that would be 1 over 4, and root 3 by 2 and root 3 by 2, that would be 3 over 4. So the final answer will be 1 plus 3, which is 4. 4 divided by 4 or 1. Let's take the second expression, cos A cos C minus sin A sin C. And that would be similarly, we can plug in the values from the upon simplification, both part of the expression, they come out to be same. It's subtraction, so the final answer will be 0.